Hello everyone. I welcome you to the new section where we discuss about BigQuery architecture for data ingestion. Data ingestion, as we know, is a base of any data pipeline. Everything starts from data ingestion. Once data is there, we start transforming it and taking it ahead. So what ingestion actually is? Ingestion is a mechanism to bring data into your data warehouse. And in our case, our data warehouse is nothing but BigQuery. To learn more, we'll see the ways we can load the data into BigQuery. There are majorly three ways, you know, categorized how you can load the data into BigQuery. We'll see all of them. So we should begin with this. And one request, if you feel that you are I am pacing a bit, I'm going fast, you can slow down the video with the speed on the YouTube section. Also, uh, please note to like and share or subscribe if you find this video informative. So let's begin this session. We'll see the ways to ingest the data into BigQuery. So what are the different ways? We'll see uh, to how to ingest the data. But before that, I'll explain what data ingestion actually means. So data ingestion is, the way to, load the data into BigQuery. So BigQuery processes terabytes in seconds, okay, because its analytical powers relies entirely on speed, efficiency, and reliability of your data ingestion pipelines. Your raw data moves at a different velocity. We know that. Okay. Selecting a wrong ingestion method will introduce latency, and it can inflate cost, and it can also compromise the data integrity. What do we mean by this? So raw data, as we know, it can be in any format: CSV, API calls, Parquet, Spark load, Spark streaming, Kafka, CDC, anything could be there. But it depends upon the way we load it. So ingestion imperative explains the way we approach the ingestion mechanism. So pipeline architecture, it requires the matching the logistic. Okay, if you have to ship a courier, you will probably box your courier items and then ship it, which means you don't want to make it break. So you will ship it a courier box, and you will give it to the shipping company, and shipping company will take it ahead and ship it to the right destination. So this is one way of thinking about you shipped the product, or whatever courier you thought of. Similarly, in ingestion pipelines, the architecture matters. The way you logistic it, the mechanism for a specific workload, it depends. So the if the workload changes, your pipeline architecture changes. So there are three different paths to load the data into BigQuery, which is our warehouse. So one is batch loading, which is specifically best for massive volume, highly configurable stuff. Another is storage write APIs. So this is new, uh, recently came into picture. Uh, with storage write APIs, you get continuous, exactly once delivery, which is the best part out of it. With PubSub, you get exactly once, but there are still problems. There are some dependencies there, but storage API, write APIs give you sub latency, sub second latency with a faster speeds and continuous. So best for streaming loads. Okay. Then the third one is data transfer service. So you want a conveyor belt kind of a structure, wherein you just push the data, and everything in managed, it's on its own. In above two approaches, you have to build your own application code, you have to write the application code, you have to decide what to do, how to do, you have to plan everything, exception handling, logging, you know retry mechanisms. Everything has to be done on the first two ways: batching and storage, write APIs. But on the data transfer service, it's zero code, You don't need to do anything. It's managed automation for SaaS products and Google ecosystem sources. Maybe you want data from Google Analytics 4, you want data from Google Ads, maybe you want to stream the data from YouTube, uh, you know any other ecosystem, and falls with maybe from Azure or Amazon Cloud. This is the best way to go through. Now we'll see all these ways or paths of loading in detail. So I'll start with batch loading first. Okay. So what is batch loading? Data engineers are very good at this. Data engineers know what is batch. A single file or a group of files, accumulated together and packed together and just pushed into data warehouse. It could be any command, whether it's a CLI, Python script, any other way. BigQuery gives a lot of ways. BQ load commands, there is export, import ways to load the data, load data commands to load from SQL statements. So this is pure batch loads, default mechanism for moving massive historical, and scheduled data, daily loads, hourly, you know, uh, monthly, weekly, best for cloud storage, or you are moving from local machines into BigQuery tables. So while you are doing batch load, you should be aware of the efficiency metrics. So batch loads, when we talk about specifically, it's files from GCS. Okay, what could be the format of the files? Avro, Parquet, ORC, or CSV JSON. So one is binary data and another is text data. Okay, so flat files and binary files. So here is a matrix of 3 by 2, which actually helps us to understand the ideal use case, compression efficiency, and architectural needs. What is the architectural need? Does the client want binary? Does the client has already binary columnar value files, or client has text files, or JSON files? Decision has to be made then and there. Okay. Compression efficiency, parallel leads with comes with binary supported formats, which is Avro, Parquet, and ORC. It is highly efficient. It supports you know the filter mechanism, also filter uh, conditions also go through uh, the queries, and you can push in the filter condition, and then filtered data can be pulled in and pushed to the BigQuery. So that is also one benefit of the binary files. In CSV and JSON, if we talk about compression efficiency, they are not compressed, so they are actually sequential reads, line by line. So there is a processing bottleneck there. We all know that. So which one to use? So ideally, Avro, Market, and ORC are preferred because they have fastest load time and lowest cloud cost, also because they are uh, smaller in size because of compression. Uh, but if there is a way that which you already have accessible human readable data, it's good. If you already have CSV or JSON, that's also makes sense for an ideal use case. So it totally depends upon your use case. If you already have CSVs and JSON, try to figure out a way to switch to Parquet and Avro or ORC. Now we'll see the ways the which BigQuery tables, or the right dispositions BigQuery provides to to load the data. So if you see, BigQuery provides you the basic default shared pool of pipeline, which you can use for batch pipelines to shared pool of slots. So you can use that slot and can load that data. There is no guaranteed throughput, but yeah, it still works. Industry is using this worldwide. There is least amount of noise that this fails or something because of not getting the slots, but the default shared pool also works well. There is a way to get a dedicated pipeline slots also if you want predictable throughput. And coming to the write disposition, uh, there are ways you can specify in your application code how you want to load the data. You want to append it, right? Append is there. You want to write truncate, you can just truncate every time you load it. Or if you want to write empty, which is for a safety lock, fails if the table already contains the data. So if you want to check before writing, you just use that right disposition in your application code. So this way it helps to manage the batch loads also. With this, after we completed the batch load, I'll move to the second approach, which is storage write APIs. This is high speed rail. Okay, so if you understand it from the very beginning, I was trying to explain that this is for sub latency write operations. So how it works is a unified data ingestion API works behind the scene, and this ingestion loads the data using protobufs. Okay, so this is not JSON, so it is gRPC. So there is proto data. So JSON and proto, there is a bit of differences, you can read about it. So protobuf is behind storage write APIs. It writes records directly into BigQuery storage directly. So no GCS involved, no temp bucket involved. Without waiting, you can write the batch files to form. Okay, so we don't want to batch the files in GCS bucket, and you can directly load it. This is designed specifically for when you have events and IO telemetry, low latency analytics. So writing, okay, no reading, only for writing. There is a read API also, which we'll discuss later, but this is specifically for storage writing mechanism, ingestion mechanism for BigQuery. So why gRPC wins over REST? Okay, so you need to understand this is recommended. Okay. Uh, REST APIs, we all know they are JSON heavy, okay, string based, and standard API pricing is there by Google. While in gRPC you get first 2 TB byte month are free. So 2 TB byte, it's too much actually. It's free, so people should use it, and at least once. This is a major difference, at least once versus exactly once. So exactly once means there will not be a duplicacy, so which comes with gRPC, which is our storage write APIs. So in your application code, if you are using REST APIs, you need your application code to maintain deduplication. Otherwise there will be problems of duplicacy, and you will have to further down the line deduplicate it in your downstream. But in gRPC, you by default get exactly one semantics. Okay, utilizing stream offsets, so which is one of the concepts of streaming. Now coming to the structure, so in REST, it's a rigid structure. You can't change the schema has to always match. If you have a background of APIs, fast APIs, or any other way of loading via APIs, you would understand this. Otherwise in gRPC, so API automatically detects the schema on the fly, and it notifies the client without dropping the connection. So which is one of the another importance of gRPC, going with gRPC. With this, I come to the explanation of committing, which is acid part of it. you know uh, while we are utilizing storage write APIs, we also need to understand how the APIs rolls back the commits or writes when there is a failure happening. So you need to understand that if there is an streaming approach, data can be taken care by multiple streams on a multiple worker environment. So API automatically makes sure that no two messages share the same offset, which is one of the requirements for making sure that each worker gets a different offset, so that you can are segregating the data, which is no deduplication. Okay, so already deduplicated data is there, so which prevents the duplicacy at the API level itself. And multiple workers can create a stream in parallel. So what will happen is that there might be a failure to load one of the stream, okay, streamed data. Then there is atomic commit to it. Atomic commit means once all workers finish the entire batch, then only it is committed. All the streams are committed as a single transaction. So you need to understand transactions here before understanding this concept. But transaction, as we all know, by a basic of acid, if you want. So we are not talking about complete acid as in consistency, isolation, and durability, but we are still talking about atomicity here. That if a transaction has been started, it would be committed successfully if all the streams have written successfully. If it fails, it rolls back. So this is another advantage of using storage write APIs. Now coming to our last approach, which is data transfer service, the automated conveyor. So why we call it automated conveyor? So if you are seeing this diagram, and you can also think about, there is somewhere a conveyor belt setup. You just place the packet and the box reaches the BigQuery. How does this happen? There is zero code, so you just automatically get a conveyor belt from Google, and that conveyor belt touches one of the sources. Maybe it is S3 Azure storage, or it could be any of the SaaS platforms. So you can think about any of the SaaS platforms. You can get data directly if there are connectors. So Google already gives a lot of connections by default. You can see the documentation for data transfer service. So this will help you understand why this is the best way. If you don't want to any code to come into place, and zero application code, zero managing, with all logging and retries. Okay, so fully managed automation. But yeah, there is a thing to understand here, that if you think about just ingesting and no other ways to think about it, then this will just work till the uh, BigQuery layer, and after that you will have to apply transformation on top of it. So data transfer service is one of the way. So this is a fully managed zero code solution, okay, for recurring schedules. Your analytics team lays a foundation for the data warehouse without writing a single line of code. We all know that. How does DTS now understand the gap? So there could be a thing that there was a gap, and on Monday or Wednesday there was if you understand from the conveyor belt scenario which is displayed on your screen, then you can think that some outage happened, and it needs a recovery. Okay, your conveyor belt needs a recovery. So after that you have to do a backfill. You want the data which was package which was not arrived on Wednesday. So you can initiate an automated backfill, okay, to rewind to the timeline. And this is one of the features of data transfer services. Amazing service. Try to use it. We are using it in our projects. uh, it helps in a way to directly fetch the data. You can also use SQLs on top of it if you want to limit some of the data. So wherein you provide the SQLs to the data transfer service. So what type of transformations, if you want to apply, you can do that. There is an SQL can be provided, but that also depends upon the source and destination. Okay. Basically, between two big queries, if you are replicating from different regions, from let's say from uh, India region to US region, um, same. the warehouse is BigQuery, you can still apply SQLs on top of it. So it has intelligent recovery. Service automatically reconstructs the missing historical window. Another benefit of using this. Now I'll come to the very end of, I'm very close to the end of this presentation, where I would like to differentiate between the three ways of loading. uh, I have created a matrix for you, which is 4 by 3 matrix, wherein on the column side, if you see, there is major differences, which is latency, coding required, cost structure, ideal workload, and the three approaches. So if you talk about latency, batch load is minutes to hours. Okay, it depends. Storage write is milliseconds. So I already told you it is sub-second latency. Okay, you want to push data whenever it lands into your API. You want to push it to BigQuery. That's it, and you want to see your reports on top of it. Data transfer service is scheduled daily or hourly, so it's a scheduled job. You still get benefits, but yeah, latency is daily or hourly. Coding required, yeah. So batch load does involve coding. It could be SQL, CLI, application code, client libraries, Python, Java, any of them. Batch loads can be done by any of the approach. Storage write APIs, you have to code a lot. You know, there is coding required here: Java, Python, Go, client logic. You have to build it from scratch. In data transfer service, zero. It's a UI configured. Just you consume it. Cost structure: batch loads are free. There is a way to load the data. Batch loads, they are free. Okay. Cost structure for storage write API. So first 2 TB byte per month is free, and then for data transfer service, it depends upon the service which you are using. So you'll have to see the pricing. So ideal workload, right? So batch loads are for massive historical, migrations, nightly reporting loops, drops. So you want your reports or your dashboards, which are dependent upon massive historical data, trends, jobs, and blah blah. But in case of storage write APIs, if you want live dashboards, IO telemetry, fraud detection, this is the best. You should go with storage write APIs. Data transfer services best for SaaS integration and automatic ad tech pipelines. Best for SaaS. So if you already have a SaaS product, think about data transfer service and the connections with BigQuery. Now, how to decide which one to use? So if you are, this will help you. Okay, this flowchart will help you to decide. If you are actually requiring a real-time analytics, go with storage, right? No. Do you have an engineering resources to maintain a custom pipeline code? Yes or no? No. So you don't have. You just pull the data, via data transfer service. If you have people who can write the code, you know, and people can ingest and manage the continuous stream of files, best way to go is batch load. So architectural guardrails, I want to share with you that there are limits and quotas for everything in BigQuery. So similar applies for load also. Hard limit of 1500 load jobs per table per day. Basic. You cannot increase that. But this is way too much. 1500 jobs per table per day is still okay. People don't hit that much. Then there is wildcard limitation. So there is only one asterisk apply. So if you are aware of high partitioning, uh, so you can at the end of your the slash, which is the last slash, there can be only one star. So you cannot specify the bucket names in between. So have to make sure that star is used for files, not for buckets. So last is for the bandwidth trade-offs, right? The faster loads and the lower cost. So you have to decide between which one you are going with. So faster loads are parallel, which is, as we saw, it was by binary, uh, and then they are not they are actually compressed. So since they are compressed, they will give you know the lower cost. So I would like to end this video while explaining one major thing here is that your architectural needs, they depend upon four major things, velocity, volume, and value. So how you decide the workload, how you decide to move, how you decide to architecture actually comes from, these three V's actually: velocity, volume, and value. So actually decide how you want to move. Uh, so if you want to move faster, you will use storage APIs. If you have time, you will use batch. If you don't want to include any application code, you will use DTS. So I hope this video helped to understand which approach to go and which approach to use for loading the data. So see you in the next video. We'll probably do a demo for this one later. Stay tuned and thank you for watching the video. Thank you. Bye bye.